Okay, we're going to take a look at part 2 of rational exponents. This is where we're going to have to do some simplifying. So if we look at this, we could kind of think about this in two ways. We could look at it as, well, this is 27. There's no plus or minus sign there, so we could give this to each one. We could say that's 27 to the 1/3 and x to the 1/3. So that's one way that we could think about it. We could also think about it this way. This is the denominator, which means that's the index. And that's in parentheses, so that would be like saying the cubed root of 27x. Okay, this one looks like it's going somewhere for me. I know that 27 is 3 times 9, or 3 times 3 times 3. Okay, that's good. So I have the cubed root of 3 times 3 times 3 times x. So my sets of 3's gets to come out. And so I have 3 cubed roots of x. So that is, that's how I would do that one. Now, if I had to write this in a, back in a rational exponent form, I could do that. An equivalent expression, you don't always have to, you just have to look at what answer they're giving us. So an equivalent expression would be 3, that's on the outside, and then we'd have x, and x is raised to an index of 3, the 1/3 power. So all of these things are equivalent. We have this one, we have this one, we have this one, and we have this one. All of these are equivalent forms of this. So that is one way to, you can take it to the radical form. Now, if I wanted to go this route, I could say, well, 27 is 3 cubed. And 3 cubed to the 1/3 power is just 3. And I can't do anything with that. And so that's 3 times x to the 1/3, or this. So lots of different ways that you can look at these problems. So let's look at example number 2. Example number 2 looks like this. 32 to the 1/4 power, x to the 17/4 power. So again, multiple ways that you could look at this one. I do notice that my denominators are the same, and they're equal to 4. So that means the index is going to be 4. They both are raised to something to the 4th power, the 1/4 or the 17/4. So I'm going to go ahead and put my 32 there. That would be 32 to the 1/4. And this would be x to the 17th. And so now I can simplify it from there. So 32 is 4 and 8. It's 2 and 2. 8 is 2 and 2 and 2, because 2 times 4. And then my x to the 17th, I'd have x to the 4th, x to the 4th. There's 8. X to the 4th, there's 12 x's. X to the 4th, there's 16 x's, and I have 1 left over. I could have written all of those out. I'm just going to group them in 4 because that's how I know that they're going to have to go. So here's a set of 2's. The 4th root of x to the 4th is x. And I have 1, 2, 3, 4 of those. And so I'd have 2x to the 4th times the 4th root of 2x. Now, we could always rewrite that if we wanted to. It just depends on what it looks like on your worksheet. I don't need absolute value marks around my x to the 4th because it is an even power. And this one is a cubed root, so no absolute value marks are necessary there. So there's our second example. And now let's take a look at this one. example number 3, if I have the fourth root of 16x to the third, and I need to write that as a rational exponent. I'm going to first look at the 16, and I'm going to go ahead and break that down, and I know that's 4 times 4, so that would give me 4 2's, and then I have x, 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 and I'm taking the fourth root of it, so those are all going to come out. So I have 2 times the fourth root of x cubed. All right, so if I need to take it to rational exponents, it's really just coming up with equivalent forms, like 1/2 is 0.5. One isn't more right than the other, it's just a different way of writing it. So my x to the third is being raised to the 1/4 power, or I'd have 2x to the 3/4. So these two expressions are equivalent. So that's another type that you're going to need to be able to do today. And then I think that we're going to stop there.